Let's talk about types of triangles. Now, for our purpose to study for the high set, we're only going to talk about categorizing triangles by their sides and the lengths of their sides. So of course, there's always more that you can do. We're just trying to trim this down so that we can learn what we need to know in order to score well on the high set or the GED exam. The first one we're going to talk about is called the equilateral triangle. So get your notes out. Equilateral triangle. And that is a triangle that has all equal sides. Okay? So you need to have your notes and you're writing down what I'm writing down. You have to know what these words mean. Remember that the entire test is word problems, pretty much. So if they tell you in a word problem that it's an equilateral triangle, then you've got to know in your little mental toolbox that all sides are equal. Write this down. You're not just watching. And all angles are equal. Now, do you recall that in a triangle, tri meaning three, you have three angles, that these three angles add up to be 180 degrees? Do you recall that? So, how big are these three angles? They're all equal, but what is their size? Well, if you know you have three angles and they're 180 degrees, and you know that all three are the same size, 180 is divided by 3 is 60 degrees. So all angles are 60 degrees in an equilateral triangle. So that's equilateral. So all sides are equal, all angles are equal, and all angles are equal to 60 degrees, which you can mark with your little tick marks. Our next triangle that we're going to talk about is the isosceles triangle, and that is just a heck of a word, isn't it? So spelling it is even more of a challenge. You need to be able to say it, though. When you see it, you should be able to say it, because if you can't pronounce it, chances are you're not going to remember what it means. So equilateral, all sides are equal. In an isosceles triangle, we have two sides that are equal and one side is not. And don't let the picture fool you. You can never assume, hey, that looks like all sides are equal. Unless they're marked, you cannot say they're all equal. You can't just go by your eyeball. So instead of all sides are equal, we have two sides that are equal in length. That's what I mean by equal. Two sides are equal. And since you have two sides are equal, then that means their corresponding opposite angles are also equal. So can you see the pattern? All sides were equal, only two sides are equal. All angles are equal, only two angles are equal. Now, how do you figure out the missing angle? So, for example, if they tell you that your angle here is 45 degrees. Well, what is the measurement of your other two? They'll say it's an isosceles. One angle is 45. What's the measure of your other two? So 180 degrees is your total. All three add up. If you take out the 45 degrees for the one angle that you have, that would give you 135. Well, I sure should have used some easier math. Okay, so if you have 135 degrees, how do you find your other two angles? Remember, 135 is for the two together. So what do? You take your 135 and you divide it by 2. So 135 divided by 2 is not going to be even, but anyway, 7.5 or something like that. Okay, so your two angles are 67.5 each, And you have to add those up. If you added this, this, and this, you're supposed to get back to 180. So you can always double check yourself. And the last type of triangle we're going to talk about is a scalene. So a scalene triangle, following your pattern here, all sides are equal, two sides are equal. So guess what? Can't have one side equal because it's got to equal something else. So guess what? No sides are equal. No sides are equal. So therefore, if no sides are equal, guess what about your angles? No angles are equal either. So you can't use a little trick like this knowing they're all 60 or taking one angle out of the 180 to get to your other two. This one just means you follow the rule here that the angle A plus angle B plus angle C, all the angles of your triangle should add up to be 180. So maybe you're given that this looks like a 90, which this would be a 90-degree angle, triangle. And say this is 30. So 90 and 30, what's this one over here? We don't know. So then you would add your 90 and 30 together. So that equals 120. And then take your 180, which is your total, minus your 120. And that would give you 60 degrees. So this over here is 60 degrees. Of course, it's not drawn to scale or anything, but you get the idea. Now, here's a little trick that I learned as an adult, how to tell these apart. Looking at the letter E, capital letter E, how many lines do you have in the letter E that are going in this direction here? You have 3. How many tick marks do you have here marking equal sides? You have 3. So equilateral has 3 equal sides. All right, 3 equal sides. Isosceles, how many lines do you have here? 2. How many tick marks do you have here marking the equal sides? 2. So how many sides are equal? 2. How many angles are equal? 2. Scalene, how many straight lines do you have in an S? None. How many tick marks do you have marking your triangle to show equal sides? None. So no sides are equal. No angles are equal. If you're working along with me, you are on page 40 of your angle section where it's talking about types of triangles. So write your notes down, then go read page 40 and work their problems.